So, good day guys, welcome back to Divion Tutorial. Please kindly subscribe to our YouTube channel. If you watch this video without subscribing, you're breaking my heart. So, this is the part 2 of what matter. Go and watch the part 1. We have talked about matter, pure substance, atoms, electron, proton, neutron, metals, non-metals, amphoteric metals, allotropy, alloys, and a lot of stuff. So you must learn it. So just go back and watch the video. So we said matter can be divided into pure matter and impure matter. Impure matter can be divided into elements and compounds. So we have talked about elements. Now we are focusing on compound. So what is a compound? I say a compound is a pure substance that is made up of two or more elements that are chemically, take note of the word, chemically combined together in a fixed ratio by mass. And I wrote an example here: H2O, water. H2O is water. Hydrogen and oxygen is what? Chemically combined. Do you get it? And I say it has a fixed ratio. It means water in Nigeria is H2O. If you take that same water to anywhere in the world, it's still H2O. That is what we mean that it has a fixed ratio. So properties of a compound. The elements of the compound cannot be separated by physical means. Why? Because they are combined chemically. They can only be separated by chemical method because they are still combined chemically. A compound has different properties from the constituents. So let me give you an example. Hydrogen and oxygen make up water, but hydrogen is a gas, oxygen is a gas. But when they make up water, water is a liquid. So the compound they form is different from the what element that make up the compound. Take note of this. So example of compound: water is H2O. Everybody should know that. Carbon dioxide, CO2, carbon monoxide, CO. We have methane, CH4. So you can just drop 5 compounds in the comment section. So based on behavior when exposed to the atmosphere, compounds are classified into 3: deliquescent, hygroscopic, and efflorescent. Deliquescent compounds are those compounds that absorb moisture from the atmosphere and form the solution of the compound. Example: iron trichloride, FeCl3, then sodium hydroxide pellet, that is NaOH, then anhydrous calcium chloride, CaCl2. So I said deliquescent compound, when they are exposed to the atmosphere, you know what moisture is? They absorb moisture and they form solution of the compound. Take note of that. They form solution of the compound. So hygroscopic compounds are those compounds that absorb moisture. Take note, both of them absorb moisture from the atmosphere and become wet. See the key difference. This one absorb moisture, become solution. This one absorb moisture, become wet. But before something can form solution, it will become what? Wet first. So deliquescent compound become wet. From wet they form solution, while hygroscopic compound they become wet and stop in being wet. Do you get the difference? So we cannot say all deliquescent compounds are hygroscopic. Why? All deliquescent compound will first become wet before they form solution, but not all hygroscopic compound are deliquescent. For a compound to be deliquescent, it must go from being wet to forming solution. So JAMB used to ask this question very well. So they can just drop a compound that is deliquescent, and in the option they will not be deliquescent there. You see hygroscopic. You are free to pick hygroscopic because every deliquescent compound is hygroscopic, because before it forms solution it must become wet. Do you get it? This one absorb moisture, become wet, form solution. This one absorb moisture, become wet, and is stopping being wet. So an example is what? NaNO3. This is sodium triazonitrate 5. This is copper oxide tetraoxosulfuric acid. So take note, these two they are almost the same. The only difference is that this one, when it forms solution, while this one does not form solution, this one ends up being wet. So if you notice, these two, when they are in the atmosphere, they absorb moisture, right? But efflorescent compound are, they give out. All this one are rich kid, all this one are poor man, they are begging. This one is the poorest, it will beg, it will become wet, it will form solution. This one will pour, it will beg, it will become wet, it will rest. Why this one, they are very rich, they used to give out. So efflorescent compounds are compounds that give out the water of crystallization to the atmosphere at ordinary temperature, e.g. sodium thiazocarbonate decahydrate is written as Na2CO3.10H2O. So once this substance is exposed to the atmosphere, out of this 10 water, it will lose 9. It will be like, I don't need you. It will give the atmosphere 9. Take note, all this one, they absorb moisture from the atmosphere. Why this one is giving what? Water to the atmosphere. It will give the atmosphere 9. It will now return to something like this, Na2CO3.H2O. So efflorescent compounds give out, these two absorb, but this one form solution, this one form become wet. This question that I've said like this, if they can ask question very well, they love to ask question very well from JAMB. So I've said something here like this: all the requisite compound are also also hygroscopic. Yes, that is because before they form solution they must become wet, but not all hygroscopic substances are deliquescent. So let me now also define this again. Hygroscopy is the ability of a substance to withdraw water vapor to become wet. But if it now goes from wet to being solution, is now what? Delinquency. Do you get the point? So deliquescent and hygroscopic compounds are used as drying agents for gases in the laboratory. Take note of that. For instance, conc H2SO4 is a drying agent. So we just finished talking about pure substance compound. We have talked about the rest in the former video, so go back to watch it. Matter part 1. So impure substance is what we call mixture. So a mixture is a combination of two or more substances that are not chemically combined. Take note of the word are not chemically combined, but compound is what? Chemically combined, with which can be separated by physical means. Example, air. Air is a mixture of gases. So they asked this question in my JAMB, so I'm going to leave it to you. So air is made up of nitrogen 78%, oxygen 21%, red gas is like 1%, then carbon dioxide 0.0%. So in my JAMB they ask, what is the component of air that has the lowest percentage? So drop your answer in the comment section. Let me know if you are smart. So that is, you see, this question, as simple as it looked like, it came out in my JAMB. I'm not talking about another person. It came out in my JAMB. So take note, a mixture is physically combined. You take note, it can be separated physically. Take note, a mixture does not have what? A fixed ratio like compound. Water in Nigeria is water in abroad. But in a mixture, I can add 1 cup of rice to 2 cup of beans is what? Mixture of rice and beans. If another person adds 2 cup of rice to 3 cup of beans, it's still mixture of rice and beans. But a compound must be what? The same in anywhere. Do you get it? So types of mixture, we have homogeneous mixture and heterogeneous mixture. Anytime you hear the word homo, it means the same. In biology, there's something they call homozygote. Capital letter T for tall, small letter t for short. TT means heterozygote. So homogeneous here, it means that it looks uniform, the same. It is hard for you to know that it's a mixture. For example, when you put salt inside water and the salt dissolve in water, you will not easily know. You can go and drink the water. It's when you taste it, you will now know that what? This is a salty water, and that is a mixture of salt and water. But if you see rice and beans, that is heterogeneous mixture. I want to say heterozygous. I'm already moving to biology. Heterogeneous mixture is once you know, you don't need anybody to tell you that this is a mixture between rice and beans. Why? It can easily be separated and it can easily be noticed. So that is the difference between homogeneous and heterogeneous mixture. So I've said this before. Mixture has variable composition. For instance, the mixture of rice and beans can be 1 cup and 1 cup and 2 cup, 2 cup and 3 cup. But for compound, H2O must be what? H2O. Mixture have physical combination. The mixture retain individual properties. Very important. Like I said before, in H2O, water is different from oxygen, is different from hydrogen. This one is liquid, this one is gas. But the mixture of rice and beans, the mixture will have the properties of rice, it will still have the properties of beans. Do you understand? So mixture can be separated by physical means. That leads us to what we call separation technique. So there are different separation techniques. Separation technique is used to separate mixtures. So one of them is what? Filtration. It's used for separating insoluble solid from liquid, e.g. sand and water. If you want to separate sand and water, you filter out which one. Which one will you filter? Drop your answer in the comment section. Let me see how smart you are. So in the principle of using filtration is that difference in particle sizes. So the sand and water cannot be the same size. Do you get it? Then we have evaporation. Let me give you this example. If you want to cook, you now pour all the salt in your house inside the water, and your mommy must not know that the salt are finished. What will you do? You can evaporate the water out of the salt by what? Boiling it. What will remain is what? The salt. So evaporation is used to separate soluble liquid, soluble solid, that is salt for instance, from a solution which is salt water. So what is the principle? Difference in volatility. Volatility means evaporation or boiling. Then distillation, take note of this one very well. Distillation is used for separating mixtures of liquid with difference in boiling points. That means if you want to use distillation, the two liquids must have different boiling points. So for example, water and alcohol. Water boiling point is 100. I think that of alcohol is 75. So there are two types of distillation. Simple distillation, when the liquid have large difference in boiling point, e.g. water and alcohol, you can use normal distillation. Take note. But fractional distillation is when the liquid have close boiling point. That means the difference between the two boiling points are not much. How do we use fractional distillation for? We use it for what? To separate crude oil. We also use fractional distillation to separate. Fractional distillation can be used to separate nitrogen and oxygen because they have close boiling point. The difference is what? The difference is little. So another separation technique is what? Decantation. Decantation is used for separating two immiscible liquid. Immiscible liquid means liquid that cannot mix together. Example, anointing oil and water. If you have anointing oil, you now add water to it, it cannot mix together. Like, let me give example now. So one of them will stay up, one of them will stay down. So out of the water and oil, which one do you think will stay up? Which one do you think will stay down? So the one that is up, they will just pour it away until it remain the one that is down. That is how they do decantation. There's another one, crystallization. Crystallization is used for obtaining pure crystals of a solute. So crystallization have to do with solubility difference. It's talking about salts. Are you getting it? So anytime they're asking you to find a crystallization of salts, what you are going to check is for solubility difference. So they can ask you which separation method is used when separating a gas with solubility difference. You just pick what? Crystallization. Do you understand? Then we have magnetic separation. I don't need to explain this one. Everybody know magnet. Magnet is used to attract what? Metal. You get it? So no need to stress myself for that. Then chromatography. Take note, chromatography is used to separate mixtures of color. So anytime they ask you color mixture, you will just pick chromatography. Do you get it? Take note, this is another question JAMB is to ask. The principle in chromatography is what? Difference in migration. So they ask you, chromatography operates with which difference? With which principle or method? Is what? Migration. Do you get it? So chromatography is used to what? Separate mixtures that have to do with color. So anytime you see color and mixture in a question, don't think twice, just pick chromatography. Do you get it? And it's the chromatography operates on difference in what? Migration. I know I'm saying this. If you are doing my school CBT practice, you surely see all these questions there that I'm taking note of. Then centrifugation is used for splitting or separating suspensions at high speed. So they don't really ask much of this. Then sublimation is used to separate sublimable solid and non-sublimable solid. So what is sublimable solid? Sublimable solid are solid that once you heat them, they change to gas directly. So sublimation, like I said, is if when you change solid from solid to gas straight away. Like some, if you want to change, you can change solid to liquid, liquid to gas. No, once you change from solid to gas directly, that is what sublimation. The separating funnel is used for separating immiscible liquid. Take note, it looks like decantation. Like I said before, once you have oil and water, one will come up. But in separating funnel, they will put funnel where one of them is either the one down or up. We pass through that funnel and go outside until it remain this one or it remain this one. But in decantation, once one is up, one is down, they will now pour it away. Do you now see the two difference? But the question they always ask in this thing, what they call it, in separating method is chromatography. Take note, used to separate color. It works on principle of migration. Another one is sieving. Sieving. It work on operation of different sizes. Then crystallization, like I said, on solubility when they're talking about solubility of salts. The fractional distillation, close boiling point, that means the difference between the boiling point is not too large. Simple distillation, when the difference between the boiling point is large. Evaporation, you know what evaporation means and the likes. So that is all for separation on mixtures. Then we now have what we call state of matter. Everybody know this one: gas, liquid and solid. The particles of a gas are very far apart and are held together by weak forces. But those of a liquid are held by stronger forces than the gas forces, than the gas own. Yeah, why the forces holding solid is what stronger than that of liquid and gas. So the kind of motion in solid is what translational and vibrational, or you can just make your research on that. The the motion in solid the motion is solid undergoes, I think it's transitional and vibrational. Yeah. Then the molecules of gas are very fast, so they move very fast, and gases are compressible. That means when you spray your perfume, you can press it and do but you can't do that for a solid, you can't do that for a liquid easily. They take note, solid has a fixed shape. That means a ball, you know these things, so let me need to waste my time. A ball has a shape, right? But the liquid take the shape of a container. So if you put water inside a kettle, the water will look like the kettle shape. If you put it into a box, it will look like the ball shape. Then every other thing, you know this one, gas does not have a definite shape. Then I've said it before, gas is compressible while others are not compressible. Then take note, gas is held by the weakest force, followed by liquid, followed by solid. So the molecules of gas move easily, unlike solid. The molecules of solid, I think, is translational vibrational, so research on that. Yeah. Then phase change. So phase change means from changing from one phase to another, maybe liquid to gas, gas to liquid. What is the name? So if you are changing from solid to liquid, methane. If you want to change your ice to liquid water, you melt it. If you want to change your liquid to solid, you put it in where? Fridge, for what? Freezing. From liquid to gas or vapor, boiling. From gas or vapor to liquid is called condensation. Take note of all these things, you should know it. Then from solid to gas, and from gas to solid, or from solid to vapor and vapor to solid, is what? Sublimation. I already explained it there. When solid change directly to a gas, to its gaseous state, or when a gas change directly to a solid state, it is called what? Sublimation. Then take note, entropy means disorderliness. There is another topic in chemistry. Increases from what? Solid to liquid to gas. So the disorderliness in liquid is higher than the disorderliness in solid, because like I said, gas, in the molecule of gas, they move anyhow freely. So the gas has the highest entropy. So they can ask you between ice, steam, and liquid water, which one has the highest entropy? It is what? Gas. Entropy means disorderliness. So gas has the highest level of disorderliness because the molecules move anyhow. Do you understand? So let's now turn to properties of matter. Physical properties, chemical properties. So we know this one in secondary school. Physical change that are what? Easily reversible. No new compounds, no new substance are formed. Why chemical change are change that are what? Irreversible, and new substance are formed, energy is released. So all these things just to refresh your brain. So then chemical change have to do with what we call chemical properties. Chemical properties include flammability, precipitation, and the rest. Why physical change have to do with physical property? Physical property have to do with something like boiling point, melting point, color, anything you can see with your eyes. Yeah. So take note, physical change is easily reversible. Chemical change is not easily reversible. New substance is formed, no new substance is formed, great amount of energy is released. Example, physical change is changing your what? Your liquid to gas to solid. So if you change your water to ice, for instance, that is what? Liquid to solid. That is a physical change because it's easily reversible. If you want to change this ice back to water, you will just allow it to cool. Once it's cool, it will change to what? Water back. So that is a physical change. Physical change are change that can easily be reversible. But chemical change, like rusting of iron, is not easily reversible. If your iron starts rusting, can you say with time it will come back to its original self? No. Another one is burning. If you burn your book, can you carry your ashes of the book and turn it back to the original book? No. So that is very simple. You know this thing in secondary school. Physical change can easily be changed back. Chemical change, once you have done it, no going back. I can never go back. Oh. So please and please, I'm begging you now to subscribe to our YouTube channel if this video was helpful. So to join our free classes, send 300 plus to 09153177154. I want to end this video now, but I want to draw a diagram for you. So take note, this is matter. So this will help you understand, especially those that watch part 1. Matter is divided into what? Pure, impure. Pure is divided into what? Element, compound. Element is divided into what? Metal, non-metal, and what do you call this thing again? Metalloid. Compound is divided into what? Deliquescent. I'll shorten the hygroscopy from hygroscopy to what? Efflorescence. Then impure is talking about mixture. Mixture is talking about homogeneous. Homogeneous is talking about an heterogeneous. Then from your let me just stop here because the video is already too long. So please kindly subscribe to our YouTube channel. God bless you as you do so.